Yo, this is me, the voice behind PlayScript. Aren't you excited on creating your very first game on JavaScript? Yeah, me too. Today I've came up with an interesting tutorial to get you started on game development where, instead of the traditional vanilla JS, we'll be using a new method known as React Canvas. With the power of React, you can easily build complex games, organize your game code and also improve your game speed as well. Alright, let's start right away and break it down to the basics so that you'll understand my mechanism more clearly. Imagine you're creating a painting, but instead of using brushes and colors, you're using code to draw on a digital canvas. That's what's happening here with a game called Coin Collector. The Coin Collector game is a simple yet fun browser game where you move a player around to collect coins. This game is built using a tool called React, which is like a set of building blocks for creating websites and apps. In this game, you have a player which is a blue square, and your goal is to move this player around to collect the gold, silver and bronze coins which has different values. The game keeps track of how many coins you've collected, and you win if you reach a certain score. Let's say it's 100. If you win, the game says, game over, and stops right there. But things don't go smoothly as you think as we have 3 enemy players who get in your way and collect coins before you do. These are some super smart CPU players who are clearly aware of what they're doing. If you collect the coins before them, you win. If not, they win. This is what we're going to build now. But before that, let me introduce the star of our episode, Replit. Just like VS Code, this is also a development environment that lets you build websites and large-scale apps with an easy folder structure. The amazing thing about this is, unlike VS Code, it already comes up with settings that makes us easy to code in the form of templates. So when you want to learn a specific programming language, you can always depend on Replit for a ready-made explanation for that. Okay, now create an account on Replit or log in when you've gone to replit.com. After logging in, you will see a plus symbol here along with the Create React JavaScript button and Python button. Since we are building a React project, let's go with this React JavaScript template and give it a name. After there, let's get started on the building process right away by renaming our app JSX to Coin Collector JSX. Now recalling our game mechanism, let's say we need a canvas which is a board here. A player, enemies, coins, particle effect for coin collecting animation, magnet to collect coins fast, and a scoreboard. First let's move on to the canvas part. Here, you'll get to know some basics of how you can write your own code for the future. Okay, before this, in the typical JS, you must have heard require method to import a module, right? Unfortunately, you won't need that anymore, since this is in version of JavaScript known as ES6. To import anything, you simply use the word import to import any module and add from to indicate the package name from where you're importing it. Likewise, you can also import any code besides a package to use it anywhere. This is known as reusing and it's one of the speciality of React. For example, let's say you came up with a code of 50 different characters for your game. Can you actually write the code of them all in one code? It's impossible, or rather you can say, the code will definitely get messy and hard to read in the end. This is where you can use React and that too in separate files to store your each character designs in their respective files with the power of component. A component is this. As you can see, they both have a clear pattern and also easy to read. But if you want to write a main component in your code, use const, while for every substitute, use function. And while the const can act as a component, it can also act as a constant depending upon how you use it. For example, to write a component, you can use constant in this, but to add a constant inside the component, you will use just const and write the name of the constant to declare it. So, if you can use constant like this, then where will you be writing a function inside the component then? The answer is when you want to do a certain task. While constant may be used for component, functions are used for tasks. With functions, you can do as many tasks as you like without having to worry about anything. Yes, with this you can say that components are the block of codes made up of functions and constants to complete a specific work where the work can be broken down to tasks. And while you're at it, let's explain the concept of parent and child components for a better understanding of components. In React, components can be nested within other components. The component that contains another component is called the parent component, and the component inside is called the child component. Pretty simple, isn't it? But when you start to write longer codes, this understanding can get complex, so it's best to decide what is the parent component first. That way, you can add more child components inside it, and never get confused again. Okay guys, now let's write the main code for Canvas with writing a component for coin collector. And coming to here, I already mentioned you that Canvas is like a drawing board where you can draw freely. But inside a code, you will be drawing without using your hands, right? For that magic to happen, first, you must know how to use the digital brush, so that you can draw the object you want, and anywhere inside the canvas. To make it possible, we'll use a hook known as UseIf. Coming to UseIf, it is the magic hook of React that lets you interact with the HTML canvas directly by manipulating the DOM element of canvas. With the help of UseIf, let's declare the canvas and set the props inside to null. Now here, it's a best practice to write constant using the constant because it can also act as component as well as constant like in the typical JS. And for the naming, it's best to write ref near the name, so that you'll catch up soon on what constant it actually is, when this becomes a 500 lines of code. After UseIf from the import, the next thing we're going to use is this one, effect. I forgot to mention, but these 4 imports you're seeing here are React hooks which hooks you into using broad range of React features available. If you want to know about the features, there are just too many to discuss that I can't do it in one video. Okay, now let's not forget the effect hook. The structure of it looks like this because it helps you handle the side effects of the components, which are operations that interacts outside of JS or is not dependent on the UI of this code. The brackets you see here are the space for dependencies, the keywords that decide when to run the effect hook. If you don't have any dependency, then the effect runs without any condition. Now inside the effect, you need to declare the canvas in the CTX here. This is like taking the game board out of the box and getting our tools ready to draw on the game board. Here, canvas ref current refers to the actual canvas element in the DOM, which is our digital game board, while the getContext method is like choosing the right 2D brush and drawing properties to draw the player and the coins on the canvas. After writing these 2 lines, let's go to the end of our code and write a return statement for the coin collector game. Because the code we've wrote until now are the ones that manage calculations, manage states, handle side effects or prepare data for rendering, but not actually appear on the screen. So, to make it happen, we'll write return statement, which has the power to display your components in the screen by tagifying it. But before coming to what is tagifying, let's review on what DOM is actually. In the true context, DOM can be abbreviated as document, object, model. Here, the picture you see is an actual HTML format and also the structure of DOM. But the real fact is that it allows programming languages like JavaScript to interact with and manipulate the content, structure, and style of a web page directly. Pretty convenient, isn't it? But how does tagifying come here? While it is for standard JS and document get element by id, it's pretty easy to access DOM and make changes to it, because it's the actual structure of web page, in the form of tree nodes. Now you realized what DOM actually is, right? But we haven't gotten to the main point yet. While for standard JS, it's pretty easy to access it and make changes, it doesn't work that way for React. Because it is component based. If it is not based on DOM tree, you can't actually directly access it. But how do you think standard JS actually get the specific ID from the DOM tree if there's no such tree with that ID from the beginning? It's called making a reference. But the only difference is that React can make a reference to a DOM tree out of nowhere, while standard JS has to rely on the existing DOM structure when querying elements. When you use methods like document, getElementBeard or document, querySelector, standard JavaScript operates on the actual rendered DOM that is present in the browser. This means that you must ensure the elements exist in the DOM before you try to manipulate them. In contrast, React's approach to handling the DOM is different, due to its component-based architecture. Yes, React doesn't manipulate the DOM directly but, instead uses a virtual DOM. This virtual DOM is a lightweight, in-memory representation of the actual DOM, which is like data stored in the computer's RAM, rather than the hard disk. Yes, you get it. Virtual DOM is a RAM-like part for the system known as React, while the actual DOM is hard disk-like part for React. Now, when you start to create React components, React keeps track of their virtual DOM structure. But React's way of tagifying involves using that custom components as tags in JSX. After that, these components are then converted into DOM elements. So, when you use a return statement in a React component, you're defining how the component should be rendered on the screen. That's it. Okay guys, now let's start writing the return statement. Here, when writing the canvas tag, we'll be using the ref here because it helps you set your own properties by taking a reference from the canvas tag for drawing. After completing this, let's go beyond the horizon to see how well structured our code actually is. And now, go to the last line of code and use the term export default name to use this code on other files too. After this, let's move on to our first bonus scenario. Our touch control is simple. When we move our hands, the player move along with us except outside the canvas. So to make it happen, we'll divide the touch controls into two, touch start and touch move. Here, we don't really need touch start for the player because our touch move does the job of moving the player. But the reason why we'll be using touch start is that, in the future, when you're working on your own game, you may have to perform various actions when the object is even touched like screen effect or rare bonus etc. This will be a helpful hand for that time. Okay guys, now while we continue to write, let's be clear on what is the first thing you need to write inside here. Finding an effective method to track your player, right? That's where the getBoundingClientRect kicks in. Remember this name well because you have to use this so many times in the future. To use this method, we use the rect constant. Just like the player position in the x and y axis, we'll be using touch and touchy to find the position of x axis and y axis to find the touch points of user. But did you notice it? Is there any specific method to track the touch points of the player leaving aside the coordinates? That's where it kicks in. A stands for event, and it helps you to track where the user has touched inside the screen. Here, we use a touches client X and Y, because we can achieve both mouse and touch controls. Here, we subtract the A touches with the rect left, because to find the X point of our player, while the rect top is for Y axis. Alright, now after that, to see them in action, we'll use an event listener along with some configuration settings, and finally unmount them in the return to make it work continuously, without affecting the performance. Okay guys, now moving on to the player part. Here, we will be drawing a player to move here and there. This will be pretty exciting as it is like placing your token at the start space in a board game. For that, you need to be sure of two things: player size, let it be 20, and the position of it inside the canvas. Now let's move on to the drawing part. It's a best practice to organize your code like mine, so that you won't get confused on where to write draw code and where to write game logics. Here, the fillRect function takes four arguments: the x-coordinate, the y-coordinate, the width, and the height of the rectangle we want to draw. For the width and height of rectangle, we consider the player size, while on the other side, we take the player position of current x and y coordinates. After there, we need to actually determine the player position every time the user touch and drag them. We'll move on to the touch controls for that. Here, the next thing you'll be doing here is that, how to find the difference between your first touch point and the next touch point you'll make. But please don't assume that the drag you do is too long. Now, for that, let's use dx and dy, since it's inside x and y axis. You may have heard about dx in the differentiation concept in maths, so seeing this picture will help you understand what I was saying before. After we've dx and dy in our hands, let's redefine the player position of x and y axis to our dx and dy, so that player will actually move to your current touch and drag. But after there, we still need to update our user updated touch point, so let's redefine touch and touchy2 as the player touch starter. After updating the touch controls of our player, let's move on to our another bonus scenario, pause menu. To apply the game pausing logics, we'll be using a React hook known as userStateHook. This simplifies managing state in functional components, making them more powerful and easier to use. In other words, it allows you to create a state variable and update it in response to user actions or other events. This is a simple example to demonstrate it. Try it out yourself in a separate file to see how it works. Now coming here, since we are just testing out, let's set the game pause to false on each one of them. After there, move your cursor to the top section and start writing the pause menu just above the coin collector component. Since this is actually UI part of code, let's straight away write the return statement and start writing the button tags of HTML. While adding the buttons, don't forget to write the matching onClick to see the button on action. Okay guys, after writing the return statement, let's add some tuning to the pause menu by adding on resume, on main menu and on restart here in the props. This'll let you customize a component from the outside without having to change the code inside. Now after completing the pause menu, you'll move on to the canvas part and make the pause menu appear with a condition, if not game paused. After making it appear, we have two more tasks: draw the pause button and make sure user if it is clicked to take the action. Here, this condition means to check if the touched position of player, both x and y axis, is greater than or equal to the exact location of the pause button. Use this type of condition when you need to give a full check on whether you're clicking on an object, both x and y axis. Yes, don't forget the prep part too. Alright, here, even though it looks like the scenario is over, we miss something, don't you think? Oh yeah, it seems like we've hit a jackpot scenario. Okay, now, create an app JSX near the coin collector JSX, and import React and necessary modules from a library known as React Router DOM is shown here. We'll see more about this in the upcoming videos. Okay guys, now coming inside, here the code is divided into two parts, start screen and app. Here, the app is the actual code for the game, while the start screen is what appears first when you load the game. Now coming to the start screen, you'll be writing in UI for a headline text and button in the center using the return statement. And also, the user navigator used here is that it'll help you navigate to the root where you want to make this code visible. While the slash you see here is the root page of your domain. If you have no roots, this will simply navigate you to the start screen. Or more like, you can say that this line attach the start screen of yours to the home page of your domain. Okay guys, now let's move on to the actual routing part. Since this app part will be just displaying other codes, let's straight away write the return statement. Inside here, let's begin with the router tag. Think of router as the foundation that allows you to navigate between different parts of your app. Now coming inside the router, we use routes tag to define the different routes or pages of the application. The routes component is like a container for all your route definitions. And inside this routes container, we'll write each route to specify the path and the component that should be rendered for that path. While this looks so tedious to write for the future games you're going to write, making this setup allows your app to have a structured way of navigating between different views, making it easy to manage different parts of the application effectively. Since we have completed our routing, now let's go to our coin collector and use this user navigate hook to navigate this handle main menu button to lead to start screen. Okay guys, now that we've finished the canvas in the player part, let's go to the coins section. This is going to be somewhat tricky since writing this code will feel very complex as you may get confused on whether you're drawing or doing maths calculation. For that, let's decide the position of coins using the use of hook and also set the number of coins that will be spawned. Using numCoins and set the number of it to 10, while setting the size of coins using coin size, which is also 10. After there, we'll start generating the coins using use callback hook. The reason we use it here is that, okay, imagine setting up a treasure hunt game where you need to place coins in different spots every time you play. The generate coins function is like the game master who decides where to hide the coins each time the game starts. Now, you wouldn't want the game master to forget where they've placed the coins or to change the hiding spots while you're playing, right? That's where use callback comes in. The use callback hook is used here to make sure that our coin generating function, the game master in our analogy, remembers where it has placed the coins. It does this by creating a memoized version of the function that only changes if the function body changes. In our game, these conditions are the number of coins numCoins and the size of the coins coin size. Unless we decide to change these conditions, the function won't change and the coins will stay in their places. Okay guys, now let's start writing inside the generate coins function. We start by returning an array in the end result. The length of this array is determined by numCoins, which is how many coins we want in the game. For each coin in the array, we are going to give it an x and y position, which is decided by multiplying a random number with the canvas width minus the coin size, to ensure the coin doesn't go off the edge of the canvas on both positions. After there, we write the numCoins and coin size dependencies so that the use callback hook ensures that this function is not recreated unless numCoins or coin size changes. Yes, this is the magic behind our coin generation. The function we wrote here literally tells that create a certain number of coins using an array and once you place the coins, don't move them unless I tell you the size or number of coins that has changed. Okay, wait, but we do mention that we will be generating different types of coins, right? Now here are the coins we will draw: gold, silver and bronze using the constant coin types. And also for each coin, you'll be deciding 4 properties for the coin: value, which is the score for the coin; gradient, which is the actual color of coin; shadow, which is shadow of the coin; and at last the frequency, which is how often the coin appears for each spawn. And to make this work, we will be adding it on generate coins. Just below the x and y, write type index, and to assign a random type for each coin that will be generated, write this following expression. Here, math, random, generates a random number between 0 inclusive and 1 exclusive, whereas the math, float, rounds down the resulting floating point number to the nearest integer, ensuring that the index is a whole number. So, in short, this line tells you that assign a random integer between 0 to 1, so that a specific coin appears. For example, if the number is 0.4, then it's closer to 0.2 than 0.7. So the silver coin will be the next to appear on the screen. Yes, here the length in the coin types means the property inside the coin we wrote before. Since only frequency matches the generated random number, so the coin to appear next will be silver. Likewise, if the number is 0.9, then the next one to appear will be bronze. Alright guys, now let's move on to A. Right. You may be wondering how come I used math random and math flow so casually, right? Exclamation mark. Let me tell you a secret. For math, random, in many games, objects like enemies, power-ups, or obstacles, need to spawn at random positions within a given area. For that purpose, the pros often use math, random to generate random coordinates x, y within specified bounds of the game world. And for math flow, if you're wondering, it's precise positioning. Yes, math flow is often used to snap coordinates of an object to a grid or tile system. This makes sure that objects align properly and can interact with the game world seamlessly. Okay guys, now that we've generated our coins, let's make them appear on the screen by writing the drawCoins function. Since there are 10 coins and 3 coin types to draw, we'll use for each to go through every coins. Now after going through each coin, we need to find out what type of coin is current coin. This is achieved with the help of type index. Since we need to keep on finding out what type of coin is generated every time, we'll be using coin types instead, and save this state for future drawing using ctx save. After saving the current state, let's move the drawing position to the coin's location by adjusting for the coin size using this ctx translate. In short, we use this ctx translate to move our position to where the coin will be generated next, but since the coin is a circle, we'll move the position to the center of coin, so to draw a circle. But before drawing the circle, we need to set some parameters for the coin. First, let's go with the shadow one. Here, you will be using shadow offset X, shadow offset Y, shadow blue and shadow color. These are necessary to set the shadow behind coin. After the shadows, let's decide the gradient for the coin. Since we already wrote for the gradient of coin, let's redefine it to save some work. Okay, now we are all set to draw the coin. Since we are going to draw a circle, let's look at the way to really draw things when you're confused on why the results aren't the same. Now looking at the CTX arc, what it actually does is take other 6 parameters to draw circular or elliptical shapes on a canvas. The 6 parameters are x, y, radius of the circle, start angle, end angle, anticlockwise. For the anticlockwise, this is a Boolean value, so write true or false whether you're drawing anticlockwise. If you write false, it draws the arc in a clockwise direction. If you write true, it draws the arc in an anticlockwise direction. After drawing the arc, restore the coin state, so that the coin goes back to the saved state. Now the cycle repeats itself, so that you don't have to worry after the restore part. Oh yeah, seems like we've unlocked a bonus scenario. Here, we write this to make sure the player collects the coin when they see one. But it doesn't end there. Here, not only player and the coins collide. If the player collides with an obstacle, it should be game over, and also, if the enemy collides with the coin, he can collect it. So to summon all this, here's a simple trick to write this. Let the two things that is gonna collide be object 1 and object 2. Since they have a size, let their sizes be size 1 and size 2. Take all these four as a parameter in the check collision function we're going to write. Now for the inside code, let's start with the return statement, since we're going to write the conditions here, so that when this function is called, you can add the results there. There are 4 conditions to write. For the first one, if the object 1 is lesser than the object 2 plus its size, so if object 1 is lesser than the object 2 in size, for example, if the object 1, I mean the coin, is lesser than the object 2 in its size, here it's the player, then you can write that the coin is collected. But since you can't always guarantee that the object 1 is coin, so we move on to the next condition by writing an n. Likewise, the first condition, let's write other 3 conditions here too. Now, you can see we made the adjustments so that when the size is big, they have the advantage so that the player can collect coins in, as well as stop their game when they hit an obstacle. Here, we don't write the code to collect coins, or let their game over, because we take these objects as a reference, and apply on the later codes, where there will be different type of objects that collide with each other. So in short, don't forget that this is the code to check if objects collided with one another, so that you can use it somewhere to take any action like collecting coins. Now after completing the coins part, let's move on to the scoreboard part. Imagine that you'll be playing a game that you've created. In your typical JS, when you start playing the game, I mean, if it's a simple game, Score++ is best to manage your score logics, but when the game becomes big and more complex, it's best to use useStateHook, as it'll help make your score logics more predictable. Okay guys, now using this useStateHook, let's set the score right now. Here you will write the score is 2 parameters, score and set score. We do this for one thing. Scoref. Scoref will track the score inside the canvas, just like the player ref. The difference is that, since the coin can be of any type and it can be anywhere on the screen, we'll use this. For your understanding, here's the life cycle for it. After you're done there, come to the return statement at the ending here, and start writing the score logics with the help of JS expressions, which are the curly brackets here. Since we need to only display the text details for the score, we'll be using HTML paragraph tag, and in the middle, we'll be showing the score results using the curly brackets. Okay, now just stop right there. The reason is we've unlocked a bonus scenario. The game loop code is very crucial for our game, so take a breath and listen carefully. Okay, before moving on to our game loop function, have you ever wondered why the draw player and the other draw functions one are in the gray color? Exclamation mark. If you do, congrats. If not, it's fine, because you've only set up their functions, but not used them yet. Now here, you may be wondering why I should write these inside a function, instead of directly calling out. That's because, we are going to use all the declared functions inside a function, so that the condition to use, request animation frame, will be triggered, since this method takes one argument that is a function, to make the animation callback you want to run. It's like a smart system that tells the browser, hey, I want to make something move on the screen. Can you let me know the best time to update the picture, so it looks really smooth? Pretty convenient, isn't it? But it doesn't end there. You can achieve 3 things by using this. At first, it makes sure that the animations are updated at the right time, so they match up with the browser's refresh rate. Secondly, if you have a tab open with an animation, but you're not looking at it, Request Animation Frame will pause the animation. This saves battery life and computer power. Now, before moving to the final point, let's conclude one thing. Different devices have different screen refresh rates. Here, the Request Animation Frame adjusts the animation timing to work well on all screens, whether it's a standard 60Hz monitor or a fancy 144Hz gaming screen. Yes, it's an amazing function as you think. Okay, now let's start writing the game loop right away and reuse all the draw functions here. After doing this, now filter out every collected coins by the player and update the score every time. Yes, this is the only logics that is missing to collect the coins after the player and coin collide. For that, we'll be using coins current so that we can always keep an eye on the current state of the coins. Keeping it in mind, add the filter array method and start writing the callback, which is this brackets. Now in the context of the filter method, the coin represents each individual element in the array of coins, as the filter method loops through it. Think of it like going through a collection of items one by one, and checking each item against a condition. Now let's continue writing. After the filter, check if the collision between player and coin happens. If yes, then increase the score by 1, and remove it from the array by returning false. If no, return true, so that coin remains in the array. Okay guys, now after completing this game loop part, let's run the game to check out how it is really working. Hooray! Now we're one step ahead of completing the game. But to make the coin collection interesting, let's move on to add the particle effects, which appears after the collection. Here, the things will be simple in 3 steps. You create particles, update their position on canvas, and draw them according to that. I'll try to explain the difficult steps behind this confusing code, so follow me on what I am saying. Now I did mention that the first step is creating the particles, right? For that, let's use createParticles function and an array inside it, using newParticles constant. For the array part, create an array of 10 elements, I mean 10 particles here using array from and taking length as a parameter, since the number of objects is usually decided by length in JS. But did you notice a difference here? Here, this is slightly different from the function expression. The bracket here tells you that this is a map function. It is a little confusing, right? There's a simple rule to know when to use a function expression, and when to use a map function. Since explaining takes too much time, I will write it down here in simple words. Now you know why I used a map function, right? Since I said how it moves and where it is located, we'll be using 4 parameters here: x position, y position, velocities and velocity. And before going on to the next, think about it yourself. Since we'll be writing, update and draw for the different particles, for the different coins in the canvas, we should decide the time property for the particle here, while we still can. Here, the time property for this particle is divided into 2, lifespan, which is for how many seconds the effect lasts. Here the time is 1000 milliseconds, which is 1 second. And the next one is timestamp for when the particle is created. Let it be date now, so that the particle will appear on the right time. Now our new particles are ready to be generated. Just give it a little push to generate by using the current push. Here, this three dots you see is also known as spread operator, which is mostly used in handling arrays and objects, making it easier to manage and manipulate data in JavaScript. Here, this is used to push new particles to the particles current. If you're wondering about its use cases, here is the list. Okay guys, now let's move on to the next one, update particles function. Here the job of this is that, it updates the state of each particles in the particles current, and remove the particles that have expired. For that, it makes sure that, it captures the current timestamp, using the current time constant. Yes, now that it has the current time, it will go through each and every particles, to update them by just changing its properties. Here, the code I am writing now are the ones you've already seen in the new particles. By updating them, you'll see that the particles move in a timely manner. You'll see the meaning behind it in the next line. Here, you'll be removing the particles using the filter method which has a lifespan below than 0. Here's the simple life cycle explanation for that. Okay guys, now that we've finished creating and updating our particles, we just need to draw it on the screen, to make the before to work. Since we are going to draw every particles, let's go through each of them, using for each loop with particle is a function expression. Now inside there, we'll be drawing as usual like the coin. Decide the brush color, begin path, drawing the arc and fill the circle with brush color. Yeah, right. This one is pretty simple because, you've already drawn the coin with the same method. And after writing all these three, you will be declaring these three. While for the second and third, you should be using it inside game loop, the use case for the first will be slightly different. You remember the place where you wrote the filtering of collected coins, to update the score, right? This is where you'll be using it, along with two arguments, coin, x and coin, y, which replaces your x and y at the moment, to exactly appear near the coin. Oh yeah, it seems like we've unlocked another bonus scenario. Here, the change is that when the player collides with it, you need to end the game right there. Okay, now to start writing the code, you need to set up the same parameters like the coin. Since the game needs to end after the player collide with it, let's make the size bigger, but reduce the total numbers of it, to make gameplay not too hard. After there, take them as a parameter in the dependency of useCallback hook you're going to write. Inside the useCallback hook, let the new obstacles be an empty array. This will hold the new obstacles that will be generated. After this initialization, use the while loop to check if the obstacles you've generated is lesser than the number of obstacles that we needed. This is for the emergency summons of obstacles, just like 10 coins appear randomly after collecting. Now inside the condition, here, this line makes sure that the new obstacle object is created within the canvas width or height, but not so close to the edge. After the new obstacles are dropped at a random place, you'll check its collision with the coins. This is the code you'll be writing. Since explanation can be messy, I wrote this here for your clear understanding. Here, the sum you see is a special case. When you want to go through each of the objects in your code, use for each. If you want to check if any of your overall number of objects is behaving strange, use sum. Okay, now that we've generated the obstacles, let's write down the code for the two. It's a simple one, so follow what I am writing. So, until now we've completed canvas, player, coins, particle effects, and scoreboard, right? Exclamation mark. So, let's move on to the enemy part, who the player will be facing off on the canvas field. Here, I will be making 3 enemies to make the game interesting, but if you want to add more, feel free to, guys. For that, let's decide some parameters. It's going to be enemies constant using the use of hook, enemy size which is the same as player, enemy speed just 0.5 times slower than the player, and their detection range which is 20 out of 100. The reason why I write detection range is that, to make sure that enemies don't get score faster. You can adjust it if you want to make the enemy more faster. And since enemies are also collecting coins, let's set a different score logics for them. Now to move further, we'll divide the enemy code into 3 functions: spawn enemies, update enemies, and draw enemies. Yes, this is just like the particle effects section you've seen before. The only difference here is that you'll have to write the update logics outside the game loop and create logics inside the game loop. The reason is because enemies needs to be inside the game consistently, unlike the particle effects. Okay, now let's start writing the spawn enemies function. Here, this is the same as when you were creating new particles. Create an array of 3 enemies using the array from, and write the x and y parameters the same as it, but instead of just x and y, write these lines. Okay, after we've spawned our enemies, let's draw their shape. It's simple as the player, but at the first, since you're going to draw every enemies with the for each loop, and set the fill style to red color. Alright guys, we're down to our last step. But just writing velocity Savari isn't going to help your enemies collect their coins. So, that's why we'll build their characteristics in this code. With inserting a goal in mind, you can make any player move according to your wish. Alright, stop. I am not here to teach you any manipulation tricks, okay? Exclamation mark. How you take it seriously depends upon you. Got it. Okay, now to move the enemy towards the coin, let's assume that there is no coin near them, and the distance between them and the coin is infinity. Now we made our enemy take an interest towards the coin. Now they'll try to search for them. Since there are no coins near them, our next step is to make sure to notice the enemy that they're getting near to a new coin by analyzing the coin and its distance from them. But since their movements are random, you may never know if they're moving towards it or away from it. To make sure they move towards the coin, give them a detection range to find the coin if they're in a certain place, and let their direction be towards the coin after the desired detection range. Here, the direction x and y are the difference in the x and y coordinate between the closest coin and the enemy. This indicates the horizontal and vertical direction the enemy needs to move. Now, after that, let's write magnitude for the distance between the enemy and the closest coin, which is calculated using the Pythagoras theorem. Combining these 3, the code you see here is the movement of enemy. Here, the direction magnitude, normalize the direction vector so that it has a length of 1. This effectively provides the direction of movement for enemies in the x or y axis, while also adding speed to it. In short, you can say, the code here says that the movement is achieved by calculating the direction vector, normalizing it, and then adjusting the enemy's position based on their vector and a predefined speed. Alright guys, the enemy is near the coin. Now what's next? Exclamation mark. To collide them and let the enemy collect the coin. For that, use check collision, but instead of objects and sizes, use these, enemy for object 1 and closest coin for object 2, and since the coin enemy near is under this assumption instead of just coin. Hence it is enemy size for size 1 and coin size for size 2, since the size doesn't change either way. Now inside it, let's define the coin's current using the filter method, since the enemy is going to collect 1 coin. Here in the filter method, this line removes the collided coin from the coin's current array, and after removing, it then updates the current score of the enemy by redefining the enemy score ref. But since the coin can be of any type, for example, the coin collected by enemy can be gold, so we'll be using the coin types to extract what type of coin it was, to give the correct score for the enemy. After updating enemy's score, we still have one more task here. To make the particle effects appear here. Here, in the arguments, use closest coin instead of coin. Now, well, let's summarize this lengthy blabber. Here, when the enemy collides with the closest coin, the code removes the coin from the game world, updates the enemy's score based on the coin's value, and creates a particle effect at the coin's location, to visually signify the collection. Now looking at our progress, we've spawned our enemies in a random location, drawn their appearance, and also made them move towards the coin, and let them collect it if they're close enough. So, to make all of them work, let's declare them inside the game loop. Now try running the game. Okay guys, now that we've finished our enemy part, let's complete this to-do list by adding a magnet power-up. Oh yeah, it looks like we've unlocked in another jackpot scenario. Using voice command in a game has both plus and minus in its own way. Imagine using a voice command to activate a power-up for your game. Pretty cool, right? Now, outside the coin collector, let's write a function to handle the voice commands with two arguments, commands and onCommand. Here, commands is an object where the keys are the possible voice commands, and the values are the corresponding actions, whereas the onCommand is a callback function to execute when a recognized command is matched. Now, coming inside this OC_voice_commands function, let's use the OC_effect hook to handle setting up and tearing down the voice recognition logic. That's because you need to keep running the voice recognition when the commands and onCommand is ready. After declaring, we'll be importing the actual voice recognition logics inside, as in the JavaScript we have in WebAPI for a special case like this. We call it WebKit Speech Recognition, which is a part of Web Speech API, and available in WebKit-based browser, like Google Chrome. After the import, we'll be configuring 5 settings to take the voice recognition to the next level. Continuous, interim results, onResult, start, and the stop function. Here, the onResult is the only event handler of all of them, while the continuous and interim results are Boolean-based settings. Alright, now this is how the life cycle goes. You create a WebKit speech recognition instance, write logics to handle the incoming results, decide the parameters needed, and finally start the loop with the start and stop setup. Since this is a necessary code for a simple voice command usage, you don't need to think too hard on what this is for. But if you want to think outside the box, here's the simple explanation for the code. Now, after completing the function to handle voice commands, let's start writing the real code needed to make a magnet. Let me explain the procedure beforehand if you're wondering. First, you need to initialize the powerup state object with information about whether the magnet powerup is active and its duration. Second, you need to write the code for when the powerup is actually activated. And the third, you need to handle specific voice commands to make sure the powerup activates only when the words match. And finally, use the OC_voice_commands to listen for voice commands and let it trigger the magnet when the words are right. Okay guys, now that you know the procedure, let's straight away jump into writing the code. In the inside, we just need to turn on the powerup for 5 seconds and turn it off for the next voice command to come. Oh yeah, it seems like we've unlocked the final bonus scenario. Here, explaining everything is such a pain, so follow me on what I'm writing. And for your simple understanding, I'll leave short and sweet comments here and there while writing. our progress of making the game once again. Since this is a look back at what we need to do, we don't have to explain everything. So, there you have it, guys. Our coin collector game is a great project for anyone looking to get their hands dirty with React and HTML Canvas alongside Replit, and you can code this just on your mobile phone. And if you enjoyed this walkthrough, don't forget to like, comment, and subscribe for more coding adventures. Catch you in the next one.